Detailed explanation of the leaky bucket algorithm mind map. The leaky bucket algorithm is a rate-limiting technique designed to control traffic flow by processing requests at a steady, predictable rate. This explanation breaks down the mind map into clear, digestible sections. 1. How it works. The algorithm is based on the idea of a bucket with a small hole. Tokens represent requests. Requests are added to the bucket as tokens. Each token represents one request that needs to be processed. Bucket capacity. The bucket can hold a limited number of tokens, requests, at any given time. If the bucket is full, new tokens are either discarded, requests denied, or queued for later processing. Fixed output rate. Requests, tokens, are processed at a consistent rate, regardless of how many are waiting. Overflow handling. If more requests arrive than the bucket can handle, the extra requests are either rejected or delayed. 2. Key characteristics. Smooth traffic flow. The algorithm processes requests consistently over time, ensuring there are no sudden spikes. Simple implementation. It's straightforward to set up and requires minimal computational resources. Effective burst control. Short bursts of requests can be handled if they fit within the bucket's capacity. 3. Advantages. Steady rate control. The algorithm prevents sudden influxes of requests by enforcing a fixed processing rate. 2. Resource efficiency. Simple logic ensures that computational and memory usage is minimal. 3. Fairness. Requests are handled in the order they arrive, maintaining a fair distribution of resources. 4. Limitations. 1. Strict rate limiting. The processing rate is fixed and cannot adapt to sudden increases in demand. 2. Potential latency. Requests may be delayed if the bucket is full and must wait their turn to be processed. 3. No dynamic adjustments. Unlike algorithms like the token bucket, the leaky bucket does not allow for flexibility in handling traffic bursts beyond its capacity. 5. Practical scenarios. The leaky bucket algorithm is ideal for network traffic shaping, controls the flow of data packets in a network to prevent congestion. API rate limiting, ensures APIs are not overwhelmed by high traffic during peak times. Streaming services, maintains a consistent stream of data for a smoother user experience. 6. Step-by-step process. 1. Initialize the bucket. Set the bucket's capacity and the fixed rate at which requests are processed. 2. Add incoming requests. Each incoming request is added to the bucket as a token. If the bucket is not full, the request is queued for processing. If the bucket is full, the request is denied or delayed. 3. Process requests at a fixed rate. Requests are processed at a steady, consistent rate over time. 4. Handle overflow. Requests beyond the bucket's capacity are either discarded or queued. 7. Example workflow. Bucket capacity, 5 tokens. Output rate, 1 token per second. Timeline, time 0. The bucket is empty. 3 requests arrive, and all are added to the bucket. Time 1. 1 request is processed. 1 token leaves the bucket. 2 requests remain. Time 4. 4 requests arrive. 2 requests fit in the bucket, and 2 are rejected as the bucket is full. 8. Optimization tips. 1. Dynamic output rate. Adjust the processing rate based on traffic patterns to handle sudden bursts more effectively. 2. Graceful overflow handling. Instead of outright rejecting requests, consider queuing them temporarily for later processing. 3. Centralized management. Use shared storage like Redis to synchronize bucket states across distributed systems. 9. Why use the leaky bucket algorithm? The leaky bucket algorithm is predictable, simple, and effective. It provides burst control, manages sudden spikes gracefully. Fairness and predictability, ensures a consistent processing rate. Scalability, adapts well to high traffic systems. It is particularly useful for APIs, network traffic shaping, and streaming services where steady and reliable request handling is crucial.